Alright, so as we begin lesson 3 for the congruence unit, I actually want to flip back to lesson 2. So I'm looking at page 9 in your packet right now, and I just want to point something out to you before we move forward. I want to look at triangle J, K, L. And I want to look at the point J started at 0, 2, and when it became J prime, it went to 0, negative 2. Let's see. This is negative 2. Help me, I don't know. It went to J, went to 0, negative 2. Just take a look at that for a minute and see what looks the same and what looks different. Then we're going to look at point K, which was the point 5, 5. And when we flipped it over the x-axis, it became K prime, which was 5, negative 5. So I want you to look at that and see what's the same and different, and if it's similar to what happened in J. Okay. Now let's look at L, that was 7, 2. And when we flipped it over the x-axis, and it became L prime, it was 7, negative 2. I'm hoping that what you're seeing is that in each of these, when I flip over the x-axis, the x-coordinate remains the same. And when I flipped it over the x-axis, the y-coordinate, what happened to that? That became the opposite. So now let's go to page 14. See if I can find it. Right here at the top. Looks like this. That's lesson 3. And so what we learned in lesson 2 was that when we're reflecting over the x-axis, we change the y-coordinate to its inverse. I like to say over the x stays the same. The arrow notation rule for that would be that the point xy becomes the point x negative 1. That's the rule. All right, so I wonder if that will be the same when we talk about flipping over the y-axis. We'll scroll down. This is back again on page 9. Yep, and you have this flipping over the y-axis. This time we're going to take the point K, which is 5, 5, and it flips over the y-axis to become negative 5, 5. So take a look at what's the same and what's different. Let's look at L, which is 7, 2. And when it flips over that y-axis, L prime becomes negative 7, 2. And lastly, J, which was 0, 2, actually it stays the same because it's on the axis. So that one doesn't change because it's actually on the axis. So I'm hoping what you see is that this time, flipping over the y-axis, the x changed, and the y stayed the same. So we went through that whole process of finding the coordinates and counting to the x and counting to the y. And today what we're going to talk about is that it has a rule. So when we're flipping over the y-axis, we're going to change the x coordinate to its inverse. And that, I look, that doesn't even look like the rule. Okay? inverse, and that arrow notation rule looks like this. Negative y. So it's written here that if you flip over the x-axis, the y changes, and if you flip over the y-axis, the x changes. Whatever helps you to remember that, you need to write down to see where your notes. So now we're going to do it just with a rule without looking at a graph at all. If our original point is 7, 3, and we're reflecting over the x-axis, that means the x stays the same, and the y is the inverse. So this becomes the point 7, negative 10, 4 over the x-axis would be negative 10, negative. You can actually picture that, okay? So if you have the point negative 10, 4, it's here. And you're going to flip over the x to be negative 10, negative 4. So that if you draw a quick little sketch, you can double check that that makes sense. We're going to flip the point 6, negative 13. We go ahead and do that and follow along. Negative 6, negative 13, and 20, negative. Now, when you reflect over the y-axis, the y is there. And the x is inverse. So whichever way helps you to remember it is how you need to do it. So over the y-axis, the y stays the same, the x becomes the inverse. The y stays the same, the x becomes the inverse. Because over there, that's 10, 4. Right? Over the y-axis, the y stays the same. You take the inverse of that. Over the y-axis, the y stays the same. You take the inverse of that. So we can do this without looking at a graph. We can use the rule. This one says specifically to use arrow notation to describe the transformation. Okay, so it definitely looks like a flip because my shape is actually flipped over. So let's see if the flip is flipping over the y-axis. It's going to be 1, 3 from the y, 3 from the y. So we're taking x, y, and we're flipping over the y-axis. So the y will stay the same, and the x will be the inverse. That's all you have to write for that one. Alright, let's go to the back. Type 1. The coordinates of a point and its image after a reflection are given. Describe the reflection as over the x-axis or over the y. Alright, so let's take a look. The x-coordinate is the opposite, and the y-coordinate is the same. Over the y stays the same. So this is a reflection over the y-axis. Triangle JKL has these vertices without graphing. That doesn't mean you can't draw yourself a little sketch just to help you. Find the new coordinates of the point J, so that's just this one, after a reflection first over the x and then over the y. So we have two things happening. We're going to take xy and we're going to flip it over the x-axis, right? Which means my rule is going to be the x stays the same, the y is the inverse. Then we're going to take that point and flip it over the y-axis, which means this new point, the y stays the same, and the x is the inverse. So I always like to write the rule first so that I'm clear on what I'm doing with my numbers, and I have it laid out plan for myself. We're going to take the point negative 7, 4. We're going to keep the x the same and take the inverse of y. So easy when I have the plan laid out already. And then I'm going to take this point over the y-axis, so a negative, -7 is a +7, and a negative y is a +4. And think about that for a minute. Let's see if that makes sense. Let's take -7, 4, that's here. A flip over the x, we know would put it down here. So let's see what -7, -4 would do. Yep. And then a flip over the y, we know would put it over here. So that would be -7, 4. Something's wrong there. What did I do wrong? Flip over the y-axis, means the y stays the same. Oh, it stays the same. Maybe doing my rule ahead of time didn't work because this should be -4. Now see how I checked that and I knew that something must be wrong? That's all part of the process of math. So I'm not at all feeling like, oh, I made a mistake, the kids are going to see that. I want you to see thinking and making mistakes. So this is tricky because I can't really write the rule. I really have to do this first because this y is going to stay the same. So I'm just going to write my little same here. And then I would know that -4 is the -4. So maybe it's a better idea than to do one step at a time and then write the goal for the next one. I should have liked that better. Okay? So again, it's a thought process, and I'm so glad that I drew this little sketch to double check myself to see if I was right. And that's something you should do too, because you're always thinking and changing and evaluating how you did. Okay, so suppose you reflect a triangle in quadrant 1. This is going to require me to make a little sketch. Quadrant 1 is over here. This is 1, 2, 3, 4. Okay. Over the y-axis, in what quadrant will the image of the triangle lie? Well, here's the y. That means the triangle's going to be here. This is going to be the quadrant. Okay, so now you can practice that on page 16 and